And I'm going to share the screen with you. And what I'm pulling up is this equity valuation chapter 7 summary. Now, let's go ahead and make it a little bigger. So if you remember from chapter 7, what we were worried about is finding the value, and what we called it was an intrinsic value. So what we're really looking for is your valuation of a share of common stock. Now, in order to find the intrinsic value, you've got to know what the future cash flows are. And with stock, the future cash flows are dividends and the selling price. It's really the selling price on a horizon date, so we sometimes call it a horizon value. The dividends are not known now, but they're estimated. In fact, they're future dividends. Okay? And then the selling price or horizon value is also not known today. It must be estimated. Fortunately for us, we're going to give you that information. In real life, you've got to estimate it. And if you kind of want to see where it comes from, we can see that if you go back to the income statement from chapter 2, revenues minus costs, okay, minus interest minus taxes is net income. So if you take net income, okay, and you divide it by the number of shares outstanding, then you're going to get earnings per share. So if you can, or if you want to kind of take a shortcut, net income divided by sales was that net profit margin. So what a lot of people will do is forecast revenues and the profit margin, and that will give them net income divided by the number of shares outstanding. That gives them earnings per share. Now, if you remember, earnings per share or even net income, which is just earnings per share is just net income divided by shares outstanding. The net income could go two places. Okay? So we took that net income and we split it off into two branches. Anyone remember what the two branches were? You have to unmute yourself. Two branches. All right, well, the two branches that it's going to are just either dividends or retained earnings. Retained earnings was basically reinvesting back into the firm so the company could grow into the future. Yeah. So whatever they didn't pay out as a dividend, they retained. So what we have is something called a dividend payout ratio, which tells you what percentage of earnings per share is paid out as the dividend. Okay. Now, to figure out 1 year at a time, a lot of people look at past revenues to figure out what future revenues would look like. And essentially, they'll figure out, hey, if you're retaining some of those earnings, then maybe there's some sort of growth rate that you can assign to future revenues. All right. The other thing we might look at is, all right, well, if we look at profit margins, okay, and we look at return on assets and return on equity, we can kind of figure out what's possible in terms of future performance to the company. We also need to consider changes in the company's management, maybe new products. Are there any internal or external forces that may impact future profits and might change the dividend payout ratio, blah, blah, blah. Okay. So this is all stuff that we figure out in an investments class. In this class, we just pretty much stick to the basics. Okay. But one of the things I do like to add into here is, what do people use in real life? Instead of using this constant growth idea, which a lot of the problems in this chapter deal with constant growth, instead of looking at constant growth, we sometimes take a shortcut, which is based on the constant growth multiple. And so it's called the PE approach, okay, or some multiples of earnings. Sometimes people use a multiple of sales or revenues, and they call it price to sales ratio. Um, and so what that says is like, hey, if we were trying to figure out a price of the stock in the future at some point in time t, and we knew that earnings per share at time t was going to be $4.55. Along that same line, we figured that the stock would trade at time period t at a PE multiple of 17. Then we've essentially estimated earnings per share in the future and assigned a PE multiple to it. The PE multiple is based on future growth. It's based on a lot of factors, but that's for another class. But you can kind of see this is really price per share at time period t divided by earnings per share at time period t equal to 17. And if we know, in fact, that earnings per share at time period t is $4.55, then we can solve for this equation and say, hey, that's why it's called a PE multiple. It's trading at 17 times earnings. So the price at time t is equal to 17 times $4.55. And we could come up with a horizon value at 77.35. Now, you may wonder, well, what's the PE multiple? That's beyond the scope of the class. We want to figure out what a long run growth rate is. That's, again, something for another class. But you can kind of see that what we're looking at, if today was 2014, what we're looking at, oops, my pen's not right. What we're looking at is future dividends and the future selling price. Those are your future cash flows, and what you've got to figure out is what's the present value of those future cash flows. And in order to find the present value, you've got to discount it at a required rate of return. The required rate of return we'll learn about in different chapters, but we'll eventually get to that this year. So we can kind of see, hey, here's the intrinsic value. It's the present value of the future cash flows. The future cash flows are the future dividends and the future selling price. And the future selling price is what we refer to as a horizon value. So we've got to find the present value of the dividends and the horizon value to find the intrinsic value. So that's kind of a recap summary. It's online. I go ahead and stop sharing that. It's online right now under chapter 7 summary or something. So if you want to go back and look at that, you can. Of course, this video will be posted sometime and you can listen to me walk through it, but you can read about it just as well. All right, any questions, or you want to go over some of the problems we had? I figured I'd start with some of those earlier problems. And some of the earlier problems were ones we've already done, but since it's been 2 weeks, we might as well go through 2 weeks. All right, any questions so far, or just? All right, well, let's look at the, I'm going to pull up this handout solution. All right, now we've already done these. We'll just go through a couple of them real quick as soon as I start sharing the screen. All right, so you should see the screen back up. What's the intrinsic value of ZZZ's common stock today? It's expected, and here we just tell you, hey, it's expected to pay $1.75 in dividends a year from now, and it's expected to sell for $60 at the end of next year. So if you want to find the intrinsic value, you've got to figure out what kind of return do you want. In this case, if we're looking at a 13.4% return, we're going to have to find the present value of these future cash flows discounted at 13.4%. So in order to do that, we can see that the intrinsic value, or what I'm going to call the price at year zero, is just equal to the $60 plus $1.75 discounted at 13.4% for 1 year. And if we calculate those, we should get 54.45. Now remember, some of you, I taught you how to do net present value and some other fancier features. I'll just stick to this writing style right now, but there's obviously 3 or 4 other ways to find the present value of future cash flows. You can use your calculator. Putting in future value at 61.75. N is 1, I is 13.4, solve for PV with no payments. So there's a lot of different ways. But remember, this 54.45 is your valuation. It's your idea of what it's worth. And what we said before, it's kind of like trying on a coat or a jacket. You try on the coat or jacket first, figure out what it's worth to you, then look at the selling price today. In this case, this stock would be considered undervalued because the price today is under your valuation. So you'd consider buying it. And you can figure out if you buy it for less than 54.45, 54.45 is the most you can pay to earn 13.4%. If you can buy it for less than that, you'll earn more. But we tend not to look at returns, we look at the valuation, whether we call it undervalued or overvalued. And you can kind of see in the next problem. Here we've got a stock that's expected to pay $1.25 in year 1 and $1.50 in year 2 and sell for $72 at the end of year 2. We want to earn 11.3%, so we're going to have to find the present value of these future cash flows. Since the $1.25 is only 1 year away, we're going to divide it by 1.113 to the first. The $72 plus the $1.50 is 2 years away. So we're going to divide it by 1.113 squared, and we're going to add those numbers up, and hopefully they give us 60.46. So if we rewrite it out over here, $1.25 a year from now is worth $1.12. and the $72 selling price plus the $1.50, it's $73.50, but it's 2 years away. So the present value is $73.50. 2 years away is worth $59.33. And if you add up both of those together, you end up with 60, 45. I got 60, 45, but it may just be a round on. Okay. So now what we've got to look at, if that's our intrinsic value, what if the stock is selling at 63.48 today? And it's overvalued, and we wouldn't consider it a buy, a good buy. Because if we pay more than 60.45, we'll still earn a return, but we won't earn what we require. And you can kind of see why stocks are risky. Obviously, when new information comes in, it affects future revenues, which is going to affect the future dividends, it's going to affect future growth, so it's going to affect the future PE multiple. And so that's why you can see when something like a pandemic hits and the economy shuts down, guess what happens? The price people are willing to pay for stocks gets lower, and we see the market in general, and most stocks, going down from what they were worth a month ago. All right, let me get off the screen sharing for a second. Anyone have any more questions? Let me cycle through them. Remember, you just have to unmute yourself and ask me a question. Is it kind of coming back to you? Okay. All right. Now, what if we weren't given the selling price in the future, but we were going to estimate it? All right. Well, remember, in order to estimate something, we needed to kind of go back and figure out what kind of model we wanted to use. Now, one of the options we had was a perpetuity model. And so before, remember, we said, hey, what if I want to give away $2,000 a year forever? We said, is there a way that we can find the present value of $2,000 a year forever? And I didn't go through the math to prove it to you. I just said, hey, the present value of a perpetuity is just equal to the first cash flow divided by an interest rate. And so if we were given an interest rate of, say, 5%, and I said, well, how much would you have to set aside today to be able to give away $2,000 forever if the interest rate is 5%? And I didn't prove the math. I just said, let's calculate this and see if it makes sense. So take 2,000 divided by 0.05. And I said, hey, you're going to need to donate $40,000 today so that you can give away $2,000 a year forever. And the rationale behind that was, if you only spend the interest, so if we put in $40,000 today and it earned 5% interest the first year, then the interest portion of that would be $20,000. And if you only spend the interest, you still have $40,000 in the bank, which earns 5% interest. And by the end of year 2, you've generated another 2. So if you only spend the interest from your account, how long can it last? Forever. So that was the idea of the present value of a perpetuity. But then I asked you to figure out, what if you wanted the perpetuity to grow? What if you wanted $2,000 the first year, and then you wanted that to increase each year by some constant amount, not dollar amount, but percentage. So let's put in growth at 3%. Okay. So what would happen? How much would you have to donate if you wanted it to grow at 3%? And I told you that the present value of a growing perpetuity was equal to the first cash flow divided by the interest rate minus growth. And I didn't really prove it to you, but if you want to watch a YouTube video, it's like a whole page of proof. But look what happens if you want it to grow at 3%. So the first year's 2,000, the next year's 3% higher than that. Then you're going to have to put up $100,000. So the 100,000 is going to earn 5% interest. 2,000 is going to be paid out as a scholarship. But remember, $2,000 growing at 3% means the next year you've got to come up with 2,060, and so on and so forth. Okay. And then the year after that, you got to come up with $2,121.80. And this exponential growth means every year it's growing at 3%, it's getting bigger and bigger and bigger. And so that's where this present value of the perpetuity formula comes from. Okay. We've already seen it, just kind of giving you a heads up on it. All right, any questions on the present value of a perpetuity formula? That's also kind of a review. All right, well, let's go back. And let's look at what happens when we've got a model in which we expect the dividend to be $1 next year, then $1.20 in year 2. And after year 2, we have a constant growing perpetuity. And the growth is 8%. Now, there was a couple things I forgot to mention back down here. This formula only works if 2 conditions are met. The interest rate is greater than the growth rate, and growth is constant in perpetuity. So those 2 conditions have to be met before we can use the constant growing perpetuity formula. This kind of makes sense. Now, we've got to find a couple things. We know the future dividends for 2 years, but we don't know what the horizon value is. So we're going to have to model it. And we can model the horizon value by treating it as a constant growing perpetuity. What we really want is to find the present value at the beginning of the constant growth. The beginning occurs at the beginning of year 3. The reason we call it P2 is because the end of year 2 is sort of the same as the beginning of year 3. So it's kind of, since we're using end of year cash flows with our calculator, everyone just calls it P2. P2 really is, it's like December 31st and January 1st, right after midnight. Nothing has really changed in terms of time, but we're in a different year. So the end of year 2 and the beginning of year 3 are the same. We're really looking for the beginning of year 3, but P2 is the same. the end of year 2 is the same as the beginning of year 3. So P2 is going to be equal to D3 divided by, now here they switch out a lot of times. Instead of I, they're going to use R. But I and R are often used interchangeably. So we've got to figure out what D3 is. We don't know D3, but we know D2 was $1.20, and we know that growth is 8%. Therefore, D3 is equal to D2, growing at 8%. And equal to 1.296. Okay. So now we've got D3 at $1.296. Now we know R, we know G. R was given here. G is here. Therefore, P2 is equal to $1.296 divided by 0.127 minus 0.08. Now, might as well give myself more room because you're going to need it. So if we take that, we're going to get 2757. Now, don't get all excited. That is not the answer. That is the horizon value. Now we've got to go back and do what? Now we've got to go back and figure out what's the intrinsic value. All we've done is solve for the horizon value. So now we go back and we say, hey, I'm going to get $1 in year 1 as a dividend. I'm going to get $1.20 in year 2 as a dividend. And the price in year 2, or horizon value, is $27.57. So what I've done is taken the perpetuity from beginning of year 3 on and replaced it with this $27.57. Now I have to find the intrinsic value by discounting these cash flows at the required rate of return, which was 12.7%. Since the dollar is coming 1 year from now, and the year 2 cash flow is $1.20 plus 27.57, and it's 2 years from now. I should be able to find the present value of those, add them up, and that would then give me the intrinsic value. So this is around 89 cents. $22.65. Add those together, get 23.54. There we go. All right. So those are basically the 3 types of problems. Either the horizon value will be given, solve for the intrinsic value. You'll have to find the horizon value either using a constant growing perpetuity, or you might use a PE multiple or something along those lines. Okay? But all the problems are set out exactly the same. It just depends on what information is given and what you have to solve for. All right, no questions yet? All right, let me go ahead and pull up those other problems. These are the Chapter 7 Prepare for Class. And oops. All right, so let's go ahead and look at the first one. Healthy Food just paid its annual dividend of $1.45. That'll help us find what the future cash flows are. And it said future dividends are expected to increase by 2.8% annually. So if D0 is $1.45, that dividend's already been paid. We didn't get it. It doesn't show up anywhere in the problem, except it helps us determine what D1 is. So D1 is equal to D0 times 1 plus G. D1 is equal to $1.45 growing at 2.8%. And we can find D1 as $1.4906. So what that allows us to do then, since we have constant growth right off the bat, we can find the stock price today because we can find the present value of the perpetuity starting at the beginning of year one. The beginning of year one is the same as the end of year zero or year zero. Okay. So we can just write this as P0 equals D1 divided by R minus G. And if we take $1.4906 divided by 0.112, we get 1331. So that's just basically showing the present value of the perpetuity. You won't see many problems like this from me because it kind of confuses. Most of the things that you see in real life are people estimate either 1 year in advance or 3 year or 5 year. So you either have a 1 year, a 3 year, or a 5 year outlook. And then after that, they're coming up with the horizon value. But it's just kind of a starter question. So. And it kind of helps you solve problems like this. It says, hey, what's the expected value of this stock 5 years from now? So if you want to find the value of the stock 5 years from now, you're essentially looking for the price 5 years from today. In order to find the price 5 years from today, you're looking really at the beginning of year 6. This is 1 year, 2 years, 3 years, 4 years. But you're looking at the price at the end of 5 years, which would be the same as the price at the beginning of year 6. Since you have a constant growing perpetuity, P5 would just be equal to D6 divided by R minus G. So if you want to find D6, you got to go through a whole series, starting out with what you know. D0 is $1.40. You can figure out D1 if it's growing at 2%. Then D1 would be equal to $1.428. And you could find D2, D1 times 1 plus G. Oops. Let me erase that. All right. Since we know D1, D2 is equal to $1.428 times 1.02. Or $1.4566. And then you just keep going through until you finally get down to D6. But what you'll also notice as you look at this, while D2 can be found this way, you could also substitute back in, and D2 could also be found by taking D0 and multiplying it by 1 plus G squared. Because you're taking D0 times 1.02 to find D1, then taking D1 times 1.02 to find D2. So you could get there directly by taking D0 times 1 plus the growth rate squared. So therefore, if you really wanted to find, for instance, D6, following that same line of reasoning, D6 is equal to D0 times 1 plus G to the 6th power. So D6 would be equal to $1.40 times 1.02 to the 6th. And you can get there at $1.57.7, basically. Now that you know D6, P5 is equal to D6. I don't remember what the required rate of return was. 16%. And if we take $1.57.7 divided by 0.14, end up with $11.26. And there we go. All right, let me stop sharing here. And now, do we have any questions? All right, let's go back. Let's try this business service one. All right, so this one's a little bit different. Because it says we've got a company that's not paying a dividend. And it's expected to pay its first dividend of 80 cents 3 years from now. So you're going to get nothing in year 1, nothing in year 2, and then 80 cents in year 3, and continue to pay 80 cents in year 4 and 5. Okay. Then starting in year 6, so the beginning of year 6, the company is expected to increase the dividend by 2%. And it's looking for the value of the stock today. Okay. In order to find the value of the stock today, we're going to have to find the horizon value, because the horizon value isn't given. The horizon value is the price at the beginning of when the growth is occurring, which is the beginning of year 6. But remember, the beginning of year 6 is the same as the end of year 5, so we write it as P5. So P5 is going to be equal to D6 divided by R minus G. Now, I don't know D6, but I know D6 is equal to D5 growing at 2%. Okay. So really, I can write P5 as equal to 80 cents growing at 2%. So that would be equal to about 82 cents, or 0.816, which I know should be about $8.16. Okay. I don't get all excited because we're not done. All we found was the horizon value. So we got $0 in year 1, $0 in year 2, 80 cents in year 3, 80 cents in year 4, and in year 5 we get 80 cents. Plus now we've substituted everything after year 5, the part that was growing at a constant perpetuity. We've substituted all this in for $8.16. So now we have future cash flows that terminate. We've got a horizon value and future dividends. We've got to bring these back to find the intrinsic value. So the 80 cents coming 3 years from now, the 80 cents coming 4 years from now, plus the 80 cents and the $8.16 coming 5 years from now. Okay. So the 80 cents 3 years from now is worth about 57 cents. The 80 cents 4 years from now is worth about 51 cents. And the $80.96 5 years from now is worth about $5.08. So if I add all these up, 57 cents plus 51 cents plus $5.08. I get $6.16. All right. Any questions on that one? All right, let's go ahead and look at this auto transmission one. All right, so with auto transmission, what we have now is earnings per share in year one of $4. And we expect earnings per share in year two to be $4.50. Okay. And out of these earnings, we expect the company to pay 40% of the earnings as dividends. Okay. So if they pay 40% of earnings in year one as a dividend, then the dividend in year one is going to be $1.60. And if they pay 40% of the dividends in year two, I think it's $1.80, but let me see. The dividend in year two is expected to be $1.80. So now we can kind of write this out. The dividend in year one is $1.60. The dividend in year two is $1.80. But now we've got to find a horizon value. Now remember, the horizon value in this case is they're going to use, instead of a constant growing perpetuity, they're going to use a P multiple approach. And the P multiple approach says, hey, we expect this stock in year two to sell at a price per share divided by earnings per share in year two equal to 19. And if the earnings per share in year two is 450, that leads me to believe that the horizon value, which is P2, is going to be 19 times 450, or 8550. So now I have a dividend and a selling price, and I discount them at 12%, and I can find the intrinsic value. All right, so $1.60 a year from now is worth about $1.43. and the 8550 plus the $1.80 2 years from now should be worth around $69.59, somewhere around $71.03. Oh, 71.02. How about that? Round down. All right, so that's most of the problems from chapter 7. Gives you some idea. There's also, if you go online, some problems from the back of the book. Hopefully this kind of caught you up. As I said before, I'll record, this is recorded. I'll post this at some point in time. Probably not right away because I have a 2 o'clock class, but after my 2 o'clock class, it'll show up in your Zoom file. And then a little bit later, it takes about 20 minutes to compile all this, so you can't just instantaneously put it up. And then it takes about 30 minutes to compile it on YouTube. So later on tonight, though, probably before 5 o'clock, you'll see it. You'll see it probably before 4 o'clock on the Zoom file and before 5 o'clock on like the YouTube channel if you're having problems doing it. But look for a email from me, because what's going to happen is I'm going to give you a chapter 7 quiz, and I'll give you at least a day or two to fix it, but I need to figure out, I'll probably just put it in Dropbox. I'm going to see how that goes, make sure everything works that way, and then you're going to have to get it back to me somehow. And depending on whether you want to show the work, that's a little bit trickier, but I think you guys could figure it out.
Is the format for our chapter 7 quiz going to be the same format as the previous quizzes?
Yes.
Okay.
Yes. There will be 4 or 5 questions. It's just like being in class quiz. It'd take you, let's say, 10 to 15 minutes in class is what it should take you out of class. So I expect people will do better on this. I don't know what I'm going to do about the other tests. The other tests will probably be timed. But you know, it's, I mean, I guess I could have given you the, if I really wanted to, which I can't, could have given you the quiz now and we do it for the next 15 minutes or 20 minutes, but I'll just, I'm not going to do that, obviously. So I'll just get it to you and post it, and then you'll turn it back in like a day or so.
When did you say our test is rescheduled for?
A week from today.
Okay.
So we have one more class period in which we'll do a review. Now the review will be some, we can review some stuff from chapter 7, but we'll also need to review some stuff. I forgot what our other chapters were. What was it, 3 and 6? Is that right? I haven't looked back that closely.
Yeah, something like that.
Yeah, I think that's what it is. But I'll look back and see. So even though it just says chapter 7 on the schedule, obviously what we're going to do is review back that material, because the test is, I'm almost 100% positive I'm going to have it next Tuesday, unless we have some kind of technical malfunction failure somewhere along the line. But so far it's been pretty good.
For the test, will it be the scheduled time for class, or like?
I don't know yet. I haven't thought that far ahead. I haven't really figured out how exactly I'm going to do the test. First I'm going to see how well the quiz goes, and how the quiz goes will probably determine. I certainly don't want to do like a multiple choice time test like you would take in an online class. I know I'm probably not going to do that. That doesn't make any sense for me in this class, because I mean, what happens in that one is we'll have 10 problems like you work out before, except A, B, C, or D. It's either all right or all wrong. You make a tiny little mistake and you get 0 points, or you guess at it and you get all the points. I don't like that for this class, so I'm not gonna do it.
So for the test, are we gonna have to like meet in Zoom, or is it gonna be just open for a day or something?
I'd probably just be open for the day. I don't know. I don't know. I hadn't thought that far ahead yet. I'm going to see how the quiz goes first, the uploading and downloading the quiz, because I'd like for some of you to be able to show work, but I just haven't figured out what the best way for that is. And I'll see how many people have problems uploading and downloading.
Could we just
And like I said, if it was me, I would probably, I mean, I know if it was me at my house, I would print off the quiz, write on it, scan it back in, and send it back and upload it back to me. I don't know that everyone can do that.
if we can't scan it, can we just take a picture of it and submit that?
Yeah, scan it. And I mean, you can, if you can email it to me, you can email it to yourself. I mean, not that I want to make things complicated, but you can email it to me. But if you can print it out, write on it, you don't have to scan it back in as a file. You can take a picture of it and email it to yourself, and it'll show up on your computer, and you can upload that file to me. Or if you want, just email it to me. I mean, but that's what I mean. If there's probably some easier ways around to do it than that. I mean, that's what I do sometimes when I take a picture of something. I just email it to myself, and then I can send it on as an email attachment, or upload it, or upload pictures of something to someone. I end up, instead of sending pictures, my parents are not real technically savvy. So what happens, they want pictures emailed or whatever. And sometimes I'll just send it directly as an email file, but then the file gets too large. And so what I have to do is look at it first before. So I'll just email it to myself, look at it on my email, and then forward it to them and make sure that it's not too big, because then it sometimes comes in crooked and they don't know how to rotate it. But it doesn't matter. It's just,
I know this is a little ahead, but for like about the multiple choice questions that we have for upcoming chapters, will we still be able to get free points if we were to turn that in, or like?
Yeah, I hadn't thought that far ahead either. I mean, that one I'm going to see how hard it is. That one I may actually put in as like a 2 or 3 point, like you have to do it in test format, even though I don't want to confuse people. But see, that's easy in test format to do online, but I don't want to have it. I mean, I don't want it to show up as a test and it's worth like 4 points, and then people are like thinking that's the test. Well, you had a test, and it's really the free multiple choice that I want you to do. So it may be that I do the same thing, just keep it the same way. Because if I do multiple choice and just send it out to you, and then you scan it and send it back to me, or take a picture and email it to me from your phone, either way, you know, that might work out better. But yeah, we'll probably follow that same format, although I know I could make that format easier. I just don't want to make it confusing. I don't want someone to go, oh, I thought that was our test. It's not. So, all right, what else do we have? How'd you like the Zoom class? Could you see the screen all right? Writing on it? Showed up fine?
Next time, can you tell us which worksheets you're going to be using so we can print it out?
Sure. Yeah. Yeah. I won't know next time. Next time will be anything from chapter, here, let's look at it. Next time will be anything from 3, 6, or 7. Depends what questions people have. You know what I mean? But in the future, after that one, I will. The next one's going to be, I mean, it'll be a little bit of chapter 7, but it's also going to be 3 and 6. Then we'll have a test, and then after that on 8, I'll let you know which ones we're gonna.
Are you gonna like make a review page over those chapters?
I guess so. Did I do one for the first test?
I don't remember.
I don't know. I mean, I can put some review questions up there, I guess. All right, what else we got? Anything else?
For chapter 7, if we have an uneven cash flow, can we just write Excel solution like equals NPV of whatever values we have?
Sure.
Thank you.
Mm-hmm. Yeah, and you can use Excel. I mean, that's the good thing. Also, just make sure you figure out how to use it correctly. Or obviously, you can use the app on your phone with NPV. It's pretty good too. Yeah. But remember, the reason I had you use the calculator, you'll want to learn how to use the calculator because the calculator is what you're going to have to use if you take any external exams, not this class, but later on. And so if you don't know how to use the calculator now and you're getting ready to take some kind of certification exam, you're going to have to figure out how to use your calculator because they'll let you bring in a calculator. They're not going to let you bring in your phone or a laptop. But it is nice. I mean, it makes doing all those calculations I do by hand or in my calculator a lot easier. Just stick them into your either the app on the phone or Excel's a lot easier. All right, what else? Most time, just look for an email from me. Everyone get the email from the announcement thing, and that thing worked all right. I never heard any complaints, but I assume it sends it to you as an email.
Yeah.
Okay. That's how I'll pretty much be sending you stuff in the meantime, or letting you know where it is. And I'll send you one today when I've uploaded these files. If you want to go back and review that. Oh, we might as well stop recording. No reason for all this.